Let's take a look at how we can do some work on a background thread whilst we're doing something else on a foreground thread and keeping our user interface responsive. This is great because in Ajax applications this is not so easy, whereas in Silverlight applications this is really quite easy to do. I've got the standard sort of project layout here. We've got a Silverlight project and we've got the website for testing that. And let's just pop to our initial UI in our page.xaml. And I'm just going to put a couple of things onto here. So we've got a grid at the moment. So let's take a stack panel into the middle of that grid. So let's just put that center, and let's say vertical alignment equals center, just to give us somewhere to play. And in that stack panel, let's put a text block, and we'll call that text, I don't know, display or something like that. We'll set the font size to be 24. We'll set the text alignment to be center. And we'll put a bit of a margin around it of 10, something like that. And then we'll also go ahead and put on here something along the lines of a button, and we'll call that button run or something like that. We'll put the content on there of run, and we'll have a click handler which we'll call on run or something like that. Let's put that on there as well. So we've got our button on there, we've got our text block on there. There's nothing in our text block. Let's just put some text in there and say not set. It's not set at the moment, so there it is. And we'll put a bit of a margin around our button too, and that's fine actually, we'll leave it just like that. Let's put another button in there. Let's call this button, let's have x name equals button cancel, and we'll have content equals cancel, and we'll have click equals on cancel, and just to be consistent we'll have another margin of 10 around that thing. Fantastic, so we've got a UI. So what we'll do is when somebody clicks on this run button, I'm just going to implement some simple functionality that does something in the background and updates this text here until somebody clicks on this cancel button, or until some kind of time ticks away or something like that. Now we could do this with a timer, but there is a really nice class for doing background work, things that you don't want to do periodically on a timer, but things that might actually take quite a long time. And let's go and take a look at that. Let's pop to our code behind this UI. Let's just get rid of this for a second, collapse some of that. I think we just wrote some event handlers that we don't yet have, so let's say on run, let's throw that in there. Let's also have on cancel, I think we had as well. Let's throw that in there. So these are just our UI handlers from the screen. And what we're going to use here is a class called the BackgroundWorker class. Okay, so this is something you might recognize from the desktop framework, the regular .NET framework. We'll call this worker. Okay, and we won't be too careful in here, but what we'll do is when you click run, we won't check to see if you're already running. We'll assume you're a good user interface person, and we'll create a new one of these background workers here. And what we can do with this is ask it to do sort of work on our behalf. It has an event it fires in order to do that work, and you can also report progress through this. It's really quite a useful thing to be able to use. So let's take a look at this. We can say worker dot. It has this event called do work. So let's first off go and put a handler in for that. So what we'll do is say plus equals on do work, something like that, and we'll drop that in there. I'll just collapse these down a little bit so that there's less code on the screen. So what we're saying is that when this worker does its work, it's going to call this method, and we will do all of our background work in this method here. We can also say worker dot, let's have a look at this, progress change. So let's say plus equals on progress changed. Just click tab. Let's just collapse that down a little bit. So what we're now saying is as the work is going on in undo work, we can ask the worker to report progress for us, and the way it will do that is by calling this method here. It will also deal with getting us back to the right user interface thread context such that we don't have to mess around with synchronizing our work back onto that context. We can also say worker dot run worker completed, so we can say plus equals on work completed, something like that. Let me use the IntelliSense for that, on work completed. Let's press tab. Let me collapse that down a little bit again. Fine. So this is going to run when the work's completed. And then finally we can say worker dot reports progress, let's say equals true. Let's say worker dot supports cancellation equals true. Worker dot, and all I'm going to do now is tell it to go and do what I asked it to do. So we'll say run worker async. So what's going to happen at that point is it's going to call my function on do work. It's going to stay in that function as long as I want it to, and if I report progress changes, it will drop into this function, and when I complete this function, it will drop into that function. And also, at the point where somebody clicks cancel here, what I'm going to do is say to the worker, what I want to do is cancel it asynchronously. So when somebody clicks the UI, I'm going to kill my work, and I'll have to take notice of that in this onDoWork function here. Okay, so I don't have any real work to do here, but you might have some long-running tasks. You might be doing some image manipulation, you might be sending some files to a server, you might be doing all kinds of different things. I'm going to just mock that out here essentially by having some fake work to do. So in my onDoWork function here, all I'm going to do is have an integer. Let's call this value, something like that. It'll start at 0. And I'm going to keep on working until one of two things happen. So I'm going to say while, let's do this simply in the first case. We'll say while value is less than, let's go for, or equal to 100, then we'll just loop and we'll say value plus plus at some point in there. But I also want to support the idea of cancellation. So let's go ahead here and also add another condition. We'll say and not, let's put it in some braces, worker dot cancellation pending. So we're checking two clauses to see whether we should cancel or not. Okay, so let's pretend we're doing something CPU intensive, and the way we'll pretend to do that without spinning the thread here is we'll just put a little sleep in here. So we'll say thread.sleep, and we'll sleep for 1 second, just to simulate the fact that we might actually be doing something that's quite expensive. So we're doing something that's quite expensive, we're incrementing this value, we want to report progress. So what we'll do here is we'll say worker dot report progress. And we can report the progress as a percentage. Well, for us that's easy because it's just value. But we can also report pretty much any arbitrary state that you want to pass. So any object you want to pass across into this report progress change function up here, you can see that when we look at the event args here, there is some user state. So, you know, we could use this for pretty much anything. We pass any object we want between the worker thing and the progress function. So we can, if we need some kind of rich type to flow between these two functions to report progress, then we can do that. In my case, I'm just going to flow across this value because that is my percentage anyway. And what I'm going to do with this value when we get over here is we're going to say text, we haven't built yet, let's just build, pick up that variable from the XAML. Let's say text display.text equals e dot progress percentage dot toString, something like that. I suppose we should also do something about work completed, so let's go and say text display.text equals done, something like that. Okay, let's see if we can build. Let's see if we can run. Let's enable debugging. Let's close that down. And so here we've got our UI. Let's click run. We get our timer ticking away. So we're calling that doWork function. In fact, we have a thread in that doWork function. It's going round that loop and it's firing events periodically as we asked it to into the progress function, which is then picking those things up. So just to be very clear, if we go and put a breakpoint in here, you know, we are just running around this loop. As you can see, we're sleeping for a second and then we're reporting progress, and we're popping back into the progress change function. Let's take that away. Let's press F5. You can see we're plopping into here and doing work from here as well. Let's get rid of that. And we should also be able to see if we click cancel that we drop into that done function. Because we're complete, we hit the cancellation. It might be useful to be able to know if we're in that done function, can we look at this and say, were we cancelled? So perhaps we should say if e.cancelled, then text display.text equals cancelled, something like that, which is slightly more explicit than what we had before. And if we run again, we should be able to see that this time, let's start running. We're ticking away again, doing our work, cancel. Ooh. So that's interesting. Why aren't we seeing cancelled when we click on cancel? If we look at the onDoWork function, we get this doWork event args in there, and one of the properties we can set on it is whether to cancel or not. So what we can do here is say, okay, we didn't cancel. So let's say if we did cancel that loop because of a cancellation pending, then let's set e.cancel equals to true. Let's go rebuild. Let's press F5. And so now what we should be doing is running, and if we cancel, we should see cancel. If we don't cancel, we have to wait 100 seconds, which I'm not going to try and do here. So let's just wait for 3 seconds for a moment. Press F5. We can wait for 3 seconds, but not 100. So let's go for 1, 2, and 3, and see if we now see that that thing is done. So that's cool. We see that as well. Let's go back to 100 for a second, just to let me keep that consistent. Just a couple of other things here before we finish off. Similarly to setting this e-cancel, we can also set result. So if there was some result of doing what you were doing in the background, so for instance perhaps what you were doing in the background was doing a checksum on some binary file or something, and you'd come back with a result at the end of that, you can set the result here to an arbitrary object, and then when you land into your completed function you can also grab from that event the result. So you can do that as well. And the other thing you might notice here, which is common in sort of asynchronous programming patterns, is what happens if this function here was to throw an exception. Well, if you were to throw an exception here, let's take a look at that. So let's just break this thing altogether right now by just deleting this code and throwing a new exception. We'll just throw an application exception here. Let's put the foo into it, something like that. And so what should happen here is we can look at if e.error is not equal to null, then we can say exception, let's say ex equals e.error, and I'll just put a line of code here so I can put a breakpoint on this. Let's press F5. Let's go and run that back up, and we can start running, and bingo, we're straight into that piece of code, and we can see that here's the exception foo that we just threw over there. So it's a way common in asynchronous patterns for picking up the exception that happened in the other function. Okay, hopefully you get a good flavor of what BackgroundWorker can do for you. It's a very nice programming model for doing something big and meaty in the background, or something you don't want to do, sort of hang the UI for, whilst continuing to be able to do other things in the foreground. Very simple programming model, don't have to do too much around sort of manually managing threads and so on. It does all that for you and just fires these events that you hook up in order to do the work that you want to do.